Hi guys, and welcome to this new tutorial of Blender. Many requests to extend the index viewer on geometry nodes, so for this reason I decided to extend the previous group node in a more complex way to let you choose if you want to show one index or all the indexes of your mesh. So let's get started. I'm working with the Blender version 3.4.1, and the difference between the previous version is that all the transfer attributes have changed in the new sample index. So if you didn't watch my previous tutorial, please check the video here or in the link in the description. And now we are going to extend this new index viewer with a new Boolean attribute called mono index mode. So if I enter with the tab in the group node, we can add after the source a new attribute, a Boolean attribute called mono index mode, default to false, because I think in almost all the cases you would need to show all the indexes of your mesh for vertices, edges or faces, and if you want to show only one index, you can check this new attribute. So you remember the layout. We can add two little frame here, so we can select all these nodes, press Ctrl J, F2 set position, move it a little bit, and then we can select all these nodes, Ctrl J, F2 points viewer. This is the starting point, and the concept behind this extended version is that we want to show all the indexes of our mesh. So to do this, we need one step: get the position of our indexes, not for one index that I set here, but for all the indexes. So to do this, we can easily select all the nodes inside this set position, Ctrl C, Ctrl V, G to move a little bit. So we need to move here. We can enable the snap node tool. We can duplicate the group input one time, link the source here. For each of these sample indexes we have not the transfer attribute because we have in the version 3.4.1, and for this reason we needed not a single index information but the original index of each point or edges or faces. So we need to link the attribute index here, here and here. We can delete all these dots, move this a little bit, and this is important because also in the case where we want to show all the indexes, we want to have the same features that we added in the previous tutorial. So the offsetting, the sizing, the rotation and following the camera, etc. This is why I duplicated all these nodes. So now from here we have the position of all the indexes. We can select all these nodes, Ctrl J, F2, set position, all indexes. Now for the rotation of the camera we can use the same rotation camera feature here, and for this reason I need to move this set position a little bit up and move the rotation camera frame here, because we also need this output for the massive showing feature of the indexes. Now press Shift Z to see the wireframe of your mesh. The idea behind this project is this. Imagine that you have this little example with three faces with 6, 14 and 155 indexes. I want to show this number as meshes, so to do this I need a string of all the possible digits that I can have in a number. So from 0 to 9 I have a total of 10 digits, okay, 10 items in this string. Then I will use this string in a conversion method to get the corresponding digit curves, and each curve will have the corresponding index, the same index in this case. So the idea is divide each number by a power of 10, and first of all 10 to the power of 0, then 10 to the power of 1, 10 to the power of 2 and so on, and this is 1, 10, 100, etc. And the idea is divide each index of your mesh by each of these number to get the corresponding index of the array to get the correct curve to show on the mesh. It's obvious we will need to offset each curve to avoid an overlapping effect. So we can start with 6, for example. If I take 6 and divide by 1, I have 6. If I divide 6 by 10, I have 0 point blah blah blah, and I need only the integer part, so 0. 6 divided by 100 is 0 point blah blah blah, and I need only the 0 integer, and with these 3 numbers I can get the corresponding index from this array of curves. With 6 I can get the 6 index here, and I can get the 6 curve. With 0 I will get 0, and with 0 I will give another time 0, and the final result will be 0 overlapped to another 0 overlapped to a 6, and then we will move this a little bit to get 0 0 6, and then we will hide these zeros because we need only the values greater than 0. Basically, next number 14, I will take 14, I will divide it by 1 to get 14, and in this case, because we have only 10 items in this array, so 10 curves, if I would take the curve 14, I can't because I have only 10 indexes. So for this reason, when you're trying to get an index over the string to curves node that we will use in this project, Blender will start from 0 again with a loop. So if I want to get the index 11, I have no 11 index here, so Blender will start from 0 from 10. So 0 1 2 3 4 5 6 7 8 9 10 11 12, etc. And in this way we can get the correct index over 10 or over 100, etc. Now with 14 we will get the number of 4 of the index, and we will have the corresponding first digit of our index viewer, so 4. Then we will divide 14 by 10, and this is 1.4, but we will need only the integer number, so in this case 1, and we will get the first, the index 1 of this array of curves, so the curve 1. Then we will divide 14 by 100, and we will get 0.14, and we will get the 0 index, so the integer part, so in this case the 0 curve, and this is 0. Then we will position these curves and we will get 0 1 and 4. Then we will move and shift them to get 0 1 and 4, and we will hide the zeros as described before. Last number 155. 155 divided by 1 is 155. Every 10 indexes Blender starts from 0 to pick the correct index, and we will get the 5 index, so the 5th curve in this array of curves, and we will get 5. Then I will divide by 10 and 100, and here we have 15, but for the same reason Blender will start from 0 to loop the indexes, so in this case we will get 5 another time. Here we have 1.55, and this index is this, so we will get this one. We will merge together in 5 overlapped to another 5 overlapped to 1, and we will shift these in 1 5 5, no zeros to hide in this case. So after this explanation, we will need all these arrays, so I hide for a moment the annotation, and first of all we need to add the string to curves node. This is very important, and we need to get all the digits that we need. Character spacing to 0 because we want to offset each curve of digit a little bit by the index of the digit itself, multiplying it by a value that we want, so we will decide the character spacing. We want to align these curves to the right because you know that if you start with a number on a point and you have more digits, it would be better to see the increasing of these digits to the left direction and not to the right direction. okay? It's better to see these align results in this direction, okay, and not in this direction. This is why I set here right. Now for the size, I can use the same size that we have in the group input, so I can import the group input and link the size here to have the same size as the mono index viewer. Here in this output we have what? Shift Ctrl and click. We have all the digits overlapped, so we need to fill this curve with an n-gon. Press Shift Z and this is all overlapped to each other, but it's not a problem. Select all these nodes, Ctrl J, F2, all digits, base instances. Now, second step, I need to get all the points on my mesh where we want to position our digits. So to do this, we need a method like this, but not exactly the same. So we can recreate here. We can add the group input another time. We can ask if the PEF is equal to 1 to get the point information, 2 for edges and 3 for faces. We can use a switch to get what? The mesh to points, to get the points of our mesh, vertices, edges or faces. We need here a geometry switching, so if I have the points or vertices, I want to have the mesh to points by the vertices of my mesh. Otherwise I can duplicate this switch another time and another time, and I can link the result of this equal here, the result of this equal here. And if I want the edges and not the faces, I want what? The duplicate node of the meshed point. Select edges, link the same geometry here, and I want to use this in the true switch result. Otherwise I want to use the faces equal operation, so I link these to the equal operation. I duplicate these another time, I link the same geometry and link the geometry here. Set edges to faces, and if the PEF is equal to 3, I want the points of my faces, otherwise no information. And I will link this result to the false of the previous switch and the output of this switch to the false condition of the first switch to have the correct choice. Now from this output I have the correct points of the vertices, edges or faces. Described before, here we have the set position of all the indexes of the vertices, edges or faces. Now I can select all these nodes, Ctrl J, F2, points viewer, and I call it points viewer because in this frame we will add the nodes to instantiate the points that I want to show with the digits, like this part for the mono index viewer. Now from these points we want to set the position of these points where. So the position is this, the output of this set position all indexes, because these will follow the same approach that we used in the previous tutorial. So I can directly link this output to the position, and I can press Shift Ctrl and click, and you don't see nothing because we forgot to manage in a correct way these three nodes equal. So we needed to link the PEF here, and PEF here, because we have faces in this case. We need points on all the faces of my geometry. So create a dot here. Now it's more clear. And now that we have the set position, we need to get the correct curve from this array instances described before, dividing each index by 10 to the power of 0, then 1, 2, 3, etc. So we can start with 0, and for this we can use the index, divide the index by a value that is the result of the math operation of the power with the 10 as base exponent 0. Now I can use an instance on points, on our points, and I want to instance all my digits for a moment overlapped to each face of my mesh, and then I will check this pick instance because I want to pick the correct index of this array, and Blender will start to pick the 0, 1, 2, 3, 4, 5, etc., 6, 7, 8, 9, and for the 10 you can see it will start again from 0, okay, 11, 12, 13, 14, and 15 maybe, okay, and we can link this divide operation in the instance index to the first index on our mesh. Next, because we want to use this method not for the 0 exponent, so for the first digit, but also for the other digits to show near the previous on our mesh, we can select all these nodes, Ctrl G, create a group. We can rename this instance to digit instances. We can link these points to the output to have a more clear layout. Next, H to collapse these a little bit, and we can export the exponent in the group input because we want to reuse this group node for 0 digit, digit 1, digit 2, digit 3. So we can select this attribute, set it as an integer and call it digit from 0. We can also export the digit instances to the group output to reuse. Next, we need also the rotation in the group input because we want to follow the camera, for example, and we can pass the rotation through this new group from outside. We can rename these instances in index instances. Press tab to exit from this group. We can rename it in indexes per digit, and we can link the output of the rotation of the camera feature here directly on my group node to get the correct rotation of my instances. And you can see if I press 0 and press Ctrl Shift click with the indexes per digit another time and another time to see the index instances, you can see if I move the camera, the indexes will follow the camera. Now we can start to duplicate this node group, Shift D, link the points to the points, and the same digit instances here, the same rotation to the same rotation, and setting here not 0 but 1 because we want the second digit, so we want to divide each index by 10 to the power of 1, so 10. Next we want to join this result with the next result here with the next index instances. Shift right drag, G to move, and Shift Ctrl and click to this geometry, and you can see this overlapping result. Now, as described before, we need to shift each digit by a number, and for this we can enter in the indexes per digit group node and add here a translate instances. When I want to move these instances by what? By a combine XYZ, because I want to shift only in one direction, so for a moment I will disable the follow camera, pressing 0 to the numpad, press tab to exit from this node, go to the parent node 3 here, deselect follow camera, enter in the group node, enter in the indexes per digit, and we want to translate the instances by a value. So if I press Ctrl Shift and click, we can see all the digits here of the first output of the index per digit, and we can multiply the number of the digit by a value and use it for the X attribute of the combine XYZ. We need to offset a little bit, so this is the wrong direction. We need to move to the other direction, and you can see the second digit appears in a correct way. Next, we can exit from this node and we can duplicate another time this node to get the third digit, so digit 2, because we start from 0. We can move the join geometry a little bit, link the same rotation, G to move, link the points and digit digit instances another time and the index instances here. And you can see this result. We have an error in the shifting, and we can see it because we have a 0, double 0 and 3 digits here is not correct, and we need to move these until the correct position of the digit, and this is the correct position of the digit: 0, 1, 2, 3, 4, 5, 6, etc. Now you can see this behavior. If I increase the size of my entire geometry node group, I have this bad result, so the overlapping of these. So I need to multiply the size by my scale factor to have a proportional linear shifting of my digits. So for this reason, I go inside these indexes per digit, and I will multiply this value, and I will export this first multiply input, renaming it in size, so the same size of my font. Next, I will multiply these by a number, for example, minus 0.1. In this case, I can collapse these a little bit, press tab to exit from these, and we need to set the size here. Now the size is here. We can import another group input node and link the size here, create a dot and use the same size here and here. You can change the output of this subgroup if you want to pass from one to the other, avoiding this type of layout. You can change whatever you want. Ctrl H to collapse the size. Now the number we set is wrong, so I need to fix it with correct number, minus 0.5. Perfect. Tab to exit, and we need to hide the zeros on our indexes. So to do this, we need to enter into the index per digit and use the selection of this instance on point. So you can see this. For all numbers, we want to see the first digit. We have the first digit in all the numbers, and from 10 we need only the first and the second digit. So to hide these zeros, I can ask me if the index itself is greater or equal what the result of the power mathematical operation. So if I link these to these and link the result in the selection, I have this result. So I'll explain. To better understand this node, I write, for example, for the index of 1, because 10 to the power of 0 is equal to 1, 1 is greater or equal to 1, and I want the selection. 2 is greater or equal 1, and for this reason I want the selection. 10 is greater than or equal 1, and I want the selection. So for all the numbers with this group node, so for the digit 0, we'll use all the selection checked for this instance on points node. But in the second group node, indexes per digit, where we have here 10 to the power of 1, so 10, we have these cases. We have 1 that is not greater than or equal 10, so I don't want the selection. And for this reason, the 0 index curve selected by this pick instance in this instance on points will not give you the curve to show on the mesh. Other example, 3 is not greater than 10, so I don't want the selection of this point. If I have 10 is greater or equal 10, and for this reason I want the selected point to be used in the instance on points, and for this reason I want to get the correct index to show on the mesh, and for this reason I have this one here. If I take 15, 15 is greater or equal 10, and I want the selection, and so on. But you can see for the 0 example we have no curves. Why? Because 0 is not greater than or equal 10 with a 0 exponent, because 10 with a 0 exponent is 1, and this is why we have no curves in the 0 index. So to fix this little problem, we need a little switch, and I create this dot to better understand the layout, and we need to ask if the digit is equal to 0, and only in this case I want to use 0 as the condition in the greater than or equal, and not the power of 10 with the exponent. So I want to use this output in this greater than, and for this I move this a little bit, and in the false condition I want to maintain the power of this 10. So in the cases that I described before, I don't want to use 10 to the power of 0, so 1. I want to use 0 for this condition to include the 0 curve on my mesh. For the other numbers, it doesn't care because 1 is greater than 0, and this will be selected as the point on this instance on points node. And this is the final layout of the indexes per digit. Press tab to exit. Now we need to duplicate these indexes per digit to reach 10 digits, for example, in a total. So 1 billion of indexes, for example. So I can drop this viewer for a moment, move the join geometry a little bit, create a dot, G to move, and I will create these with a time lapse. Okay, we have 10 digits here, and I set 0, 1, 2, 3, 4, 5, etc. to the correct attribute. I can select all these nodes, Ctrl J, F2 digits. Now for the last part, we can use the output of the point viewer to instantiate the same icosphere used in the previous tutorial. So we can add an instance on point where on my result mesh here, and I can use the icosphere as the instance, and don't use the radius. I will use the scale as described in the previous tutorial. In the group input here, I will link the point scale directly here, and for the same reason I will link the points boolean attribute to a switch true or false with the geometry set here. And if I want the points, I want this output of the instance on points, otherwise I don't want the geometry. H to collapse and link the points boolean to the switch, and here we have the output of our icosphere. Ctrl H to this to get only the nodes that we want, select all these nodes, G to move here, G to move a little bit up, and we can join these output with the output of our digits. And because we have these two vector lines, we can select all these nodes, G to move, and move here. Okay, we need to join the points viewer output to the join geometry here for our digits, and we can link these directly here to the join geometry. Okay, now you see this result because we forgot another little link. So the link to set position all indexes frame, so I didn't link the offset to the scale of the normal of my points, and this is why I had the wrong offset of my scale, because before I had 1 here as the offset. Now we need to link the correct set here. And now the last part, so the switch, the attribute that we added in the starting point of the tutorial, the mono index mode. So it's time to create the switch. Here from this we have the mono index viewer described in the previous tutorial. Here we have the geometry, and here we have the link of the new geometry for the massive index viewer. So we need a switch, we need the group input another time, and we need to link the mono index here in the switch. And if it is true, I want the old result of the tutorial, so the mono index viewer. Otherwise I want to link the new method, and this is the correct output to link to the viewer. So this is the final result. I can collapse these, Ctrl H to use this only mono index mode, select all these nodes, Ctrl J, F2, viewer mode, press tab to exit from the group node, link the geometry to this geometry, press Shift Alt and click to delete the temporary viewer output from this node, and this is the final shape. Now I can jump to the edges or vertices of my mesh, use the offset as I want, increase the size, avoiding the overlapping of the digits mesh of my numbers, can set the follow camera and press 0 to see the result from the camera view, and you can see the correct following behavior. And this was the tutorial. Thank you guys for watching this video. I hope you like it and I hope you learn something from it. If you want to leave a comment or check a like. If you like what I'm doing, please subscribe to my channel and check the bell icon to get the notification of all new posted videos. You can download this project from my Gumroad page or create this project from scratch. I will update the previous file on my Gumroad page with this new extended version, so you can use both of the methods that I described here in this tutorial and in the previous tutorial. So see you to the next video. Bye!